Hi everyone, so just quickly going over finishing this problem from class the other day. So we left off here with this conservation of energy equation. So we had been working on this pendulum looking at the energy from this point to this point here. So here having all potential, and then at this point having both a combination of potential and kinetic energy. So we ended up here with that bar chart, expanding that into this equation, letting the masses cancel, which brought us to this G delta Y equals V squared over 2 plus G delta Y final. And one thing that we found out here is that, well, delta Y originally is the length of the pendulum, because here is its lowest point. So here it's at a height of that L, and then delta Y final here, we drew the triangle in green, and we found that delta Y final would equal the length L minus L sine of theta, as it's this delta Y here would be this total length L subtracted from this length here, and that gave us this difference. So another way we could write this is L1 minus the sine of the angle. So here we'd have GL 1 minus sine of theta. If we subtract that over to the other side, we'd get that V squared over 2 is equal to GL minus GL 1 minus sine theta. We can even factor this, so I'm going to add another page here. So let's see, we left off with V squared over 2 is equal to GL minus GL sine 1 minus the sine of the angle. So we could actually factor out the GL and have V squared over 2 is equal to GL 1 minus sine of theta. So let's see, the 1, if you distribute the minus here, so you get V squared over 2 is equal to GL, and then this would just become 1 minus V just sine theta, or that V would be 2GL sine theta square root. So just the algebra from there. But the real important part here was the conservation of energy.